Hi there, today I would like to show you about this new prototyped bike tail light. I am using 8x ARGB panel, Arduino Nano, and HC05 Bluetooth module. Here, I am trying to print dual color from a single nozzle Ender 3 3D printer. I add a brand name Beartech on it, but I think I should use more highlighted color, such as orange or white filament. On the back side of the device, I embedded magnet in it, so I can attach it on any metal surface or the tail light holder.
Cause I also embedded a strong neodymium magnet inside the tail light holder, so it won't fall off when riding. And here is the USB port and the charging port, so I can upload an updated program or do some debugging work. All the accessible ports are facing downward to avoid rainwater get inside the device. To turn it on, just tap 1 time on the top of the device, then it will show how much battery juice left in it. If the battery is full, it will lid 4 pixel in green color. If the battery is low, it just simply turn on 1 red pixel. And now the device are in standby mode by simply just showing 1 pattern that preset previously by the remote control. To turn it off, just simply tap 2 times on the top. Inside the device is actually a touch sensor module that connected to a NPN transistor signal the 5V buck converter on or off. So here's the remote control device. The design is actually not small enough, but still, this is the first prototype. For feature or next prototype, I will remove the OLED display to reduce the size. Because I can use SMD LED to indicate the notification, signal, or the battery level as well. Here I try to design the button directly on the case to avoid easy press and also for testing, because that is the power button. To turn it on, just press 1 time. And it turn on, and showing some graphical logo and the program version. And then, it will connect to the tail light device automatically via Bluetooth module. Why I am using OLED at the first prototype? Well, it can show all the parameters such as data receive and send, battery voltage or pin input value. This help a lot when I try to debug or programming. Here left and right signal button, when press it, it will send numbers or alphabet to the tail light device to run the turn signal pattern. Press again to stop the right turn signal. When turn left, just simply press the left button, and the tail light will show the left turn signal pattern. To change the standby pattern, just press the middle one. Here the connection icon is blinking, indicating the remote control device is waiting the response from the tail light. Now the remote control showing the current LED pattern, XY matrix. Press the middle button and it will cycle to each preset LED pattern. Now it show, stop sign. May need to wait for a few seconds to allow the tail light to update the LED pattern. I try to learn how to use Bluetooth module using Arduino, but I think I should use nRF24L01 for next prototype to improve the data transmit and receive. Because the light pattern program using very little delay function like about 50 or 20 millisecond, the data send and receive timing has been affected. So here we will cycle trough each preset LED pattern. Press again to show rainbow TV effect pattern. We can see the connection icon is blinking indicate the remote control once again waiting respond from the tail light device. I should remove the delay function to reduce the respond delay problem. And here is the rainbow TV effect. Then we can see the connection icon has stopped blinking and that indicate the tail light has responded and update the LED display pattern. Press again, and the next twinkle fox pattern shows up at the display. Wait a while, then the tail light updated. At the top right corner, it indicate the tail light battery level. The left top corner showing the remote control battery level. They both using the same buck converter, same Arduino Nano, and the controller using HC05 Bluetooth module, but the tail light is using HC06 Bluetooth module. Here's the USB port for programming and debugging. And here is the USB Type-C charging port. And here I cut a little hole to read the battery level indicated from the buck converter board. We can see the buck converter board showing the battery is full, but the Arduino read and show the battery only in between 50%. An accurate read, but we'll fix this error very soon. Press the power button twice to turn it off. Thank you.